That one consists of the scale, consists of the skull, sorry, not scale, consists of the skull, consists of the sternum, consists of the ribcage, consists of the vertebral column. For example, when you talk about the vertebral column, I've told you this is basically the backbone, which is made up of 33 bones in human beings. So we start with the first one, then the skull, we see how it carries out its function. The skull, you can see it on your screen there, one that I'm sharing there. You can see the skull, that is the skull. So when we talk about the skull, this one is basically made up of the cranium. It is made up of the cranium. It has the upper jaw. The upper jaw, sometimes we call it the maxilla. We call it the maxilla. Then we also have the lower jaw that we call the mandible. So the lower jaw, the upper jaw, and the skull, they are the one that forms the skull. You can see them there. So on the upper jaw, we have it here, whereby we have the upper teeth located. Then we have the lower teeth, which are located on the lower jaw. So those two, and then we have this cranium here. The cranium, the upper jaw, and then the lower jaw, they all form the skull. They all form the skull. Now, in the skull is not one bone. It is not made up of one bone. The skull specifically is not made up of one bone. For example, that cranium. It is made up of so many bones that are fused together to form an immovable joint that is called the sutures. This cranium here, you can see we have a suture somewhere. That is just one skull that has been indicated. We have so many so many bones that are joined together by immovable joint called the suture to form a cranium. So the type of joint, one of the joint that is found on the skull is the suture, which is an immovable joint. The other thing about this one here, you realize that the upper jaw is fused to the cranium. If you try to move the upper jaw, you realize that it cannot move. The upper jaw cannot move. It is fixed. It is fused with the cranium. So what normally moves is the lower jaw. The lower jaw is the one that moves because the lower jaw and the upper jaw, they are joined together. They are articulated together to form a hinge joint. So what normally moves, even if you try now, is the lower jaw. But the upper jaw does not move. It is fused and fixed with the cranium. Now, the skull, it has some function. It has some functions. One of the functions of the skull is that it protects the brain. One of the functions of the skull is that it provides protection to the brain. Number two, it also provides protection to the olfactory organs. So when you talk about the olfactory organs, these are this is the nose, basically the nose, and the nose and the visceral organs that are leading to the respiratory organ, all the way to the lungs, etc. Olfactory organs are basically the nose. Then it also provides protection to the middle and inner ear. Remember, the ear is divided into three. We have the external ear, which is basically the pinna. Then we have the middle ear. Then we have the inner ear. That one is going to be referred to when we are talking about.
Yes, Mwalimu.
Yes. Somebody is saying something. Okay. So we are saying the three functions, or the main function of the skull is to provide protection to the brain, also provide protection to the olfactory organs, or basically the nose, and also provide protection to the middle and also the inner ear. So one of the things that you realize about the skull, even if we are saying that it is made up of so many bones that are fused together to form with the joint that are called the suture, it has some perforations. It has some perforations. So the perforations, maybe, I don't know whether you can see them clearly there. We have some perforations indicated there. Those perforations are important in that they allow the passage of the blood vessels in and out of the brain. Remember, the brain will require oxygen. It will require nutrients. So the blood vessels pass from the muscles that are found on the head. They pass through those perforations to the brain. They supply the oxygen, the nutrients. Then after respiration has taken place, there will be production of carbon dioxide as a byproduct. It needs to be removed from the brain. So we have the blood vessels again removing those metabolic waste products. So those perforations are important in allowing the passage of the blood vessels in and out of the brain. Also, the nerve endings are supposed to pass through those perforations that are found in the skull. So usually, if you look at around this area where we have the hinge joint, so the posterior end, the posterior means the back end of the skull. The posterior end, it has some rounded protuberances. It has some rounded protuberances, and also it has the occipital condyles. Those occipital condyles are the ones that are going to join or articulate with the atlas vertebra to form a joint that allow the nodding of the head. So when you talk about the atlas, remember, I've told you that the exoskeleton is made up of the skull, it is made up of the sternum, it is made up of the ribcage and the vertebral column. The vertebral column is made up of 33 bones, starting from the neck region. So the first bone that articulates with the skull is referred to as the atlas. Is referred to as the atlas. The atlas is the one that is going to articulate with the head or with the skull to form a joint that is going to allow the nodding of the head. So the first bone of the vertebral column is referred to as the atlas. It was one of the bone that make up what we call the cervical vertebra. It's one of the bones that make up the cervical vertebra. So that is the skull. Now, under the skull, there is something that is a question that you need to address again. You discuss adaptations. Discuss the adaptations of the skull to its function. Adaptations of the skull to its function can have as many as 5 points talking about the adaptations of the skull to its functions. Adaptations of the skull to its function. Adaptations of the skull to its function. Look at that. Highlight those points and discuss them properly. Now the second bone of the second bone of the exoskeleton is the ribcage, and the ribcage we are going to combine them with the sternum, because the sternum, you can see the sternum here. That is where the ribs articulates to the frontal end to this bone that you're calling the sternum. So basically the ribcage here, it protects the heart. It is the ribs, they form the ribcage. The many bones that are found in human beings, they form the ribcage. And basically the ribcage encloses a thoracic cavity, that cavity that is protecting the lungs and also the heart. So one of the functions of the ribcage is to provide protection to the lungs and also to the heart. Of course, the other function of the ribcage is that like to provide surface for muscle attachment. That is a point that the majority forget. Apart from providing protection to the lungs and the heart, the ribcage also provide a surface for muscle attachment. Usually the ribs articulate with the vertebral column to the back. you can see that the ribs are running to the end, to the back end, and also to the front end. So to the back, the ribs are going to articulate with the vertebral column. Basically, the bone, the vertebral column where the ribs are going to articulate to the back is what we call the thoracic vertebrae. We are going to look at that. So to the back, the ribs articulate with the thoracic vertebrae, and then to the front, it will articulate to the sternum. You can see these ribs are running towards the end, the back end of the rib cage, and then they articulate with the thoracic vertebrae. Then to the frontal end, the ribs are going to articulate with the sternum. You can see that. In birds, for example, the hen, the dove, etc., the sternum usually is normally modified to a bone that we call a keel. It's modified to a bone that we call a keel. So this keel is important in providing a larger surface for attachment of the pectoral muscles, or what we call the flight muscle. So the flight, the wings, or we can say the wings, they have the types of muscles that we call the flight muscle or the pectoral muscles. So those ones are normally attached in birds to a modified sternum that we are calling the keel, Now, somebody might ask you again here, you need to talk about the adaptations of the rib cage and the sternum to its function. You realize that they are numerous. These bones that are making up the rib cage, they are numerous. The ribs are numerous. The reason why they are numerous is also to provide a larger surface for attachment of the muscles. You can see the sternum is solid. It is solid. That is in order to provide firm support or firm surface for attachment of the ribs, etc., etc. You talk about adaptations of the rib cage and the sternum to its functions. That one can be another assignment of the day. The other bone that we need to talk about is the vertebral column. The vertebral column. So when you talk about the vertebral column, these ones are basically the backbone. The vertebral column are the backbones. In human, we normally say that the vertebral column consists of 33 bones. It has 33 bones that are referred to as the vertebrae. So 1, 2, all the way to 33, we call them the vertebrae. So between each vertebra and the other, because they are separated, we can say they are countable. You can count them from number 1 to number 3. They are not fused. So they are separated by a cartilage that we call intervertebral discs. So between one vertebra and another, we have a cartilage that we are calling intervertebral disc. And the intervertebral disc, the one that is separating the vertebrae, because we are saying they are 33, it has some functions. The 3 functions, you can see them there. One of the functions of the intervertebral disc is that it acts as a cushion and also absorbs the shock. Acts as a cushion. It acts as a cushion and also absorbs shock. Acts as a cushion and also absorbs shock. That is one of the functions of the intervertebral disc. I'm saying that the intervertebral disc, it is that cartilage that is separating 2 vertebrae. We have 33 vertebrae. Bones of the vertebrae, they are 33 in number. So they are not joined. So between one vertebrae and another one, we have that cartilage that we are calling intervertebral disc. The functions of this intervertebral disc, I've said, number 1, act as a shock and also absorbs them. Act as a cushion and absorb shock. Number two, it reduces friction. It reduces friction between the vertebrae. The bones are allowed, they are allowed to come into contact with each other. You can imagine the kind of friction those bones are going to experience. They are going to grind each other, bringing about a lot of pain. So to reduce that friction, we have the intervertebral disc. Next, the other thing about the vertebral disc, and the last one, it makes the vertebrae flexible to allow the movement of the vertebrae. If the 33 bones of the vertebrae are fused or they are fixed, then that is to say the organism cannot be able to move, cannot be able to maybe bend. Bending cannot happen, and those kind of movement cannot, because the organism is going to be fixed in a way that it cannot move, it cannot bend, etc., etc. So to bring about this flexibility, the 33 bones are separated from one another by the intervertebral disc, Usually, the 33 bones of the vertebrae, they are divided into 5. They are divided into 5 vertebrae, the 33 bones. We have the cervical vertebrae, the cervical vertebrae. We have the thoracic vertebrae. We have lumbar vertebrae. We have the sacral vertebrae, and then we have the caudal vertebrae. So, when you talk about the cervical vertebrae, these are bones that are found in the neck regions. They are bones that are found in the neck region, the cervical vertebrae. They are bones found on the neck regions. Usually, they are 7 in number. They are 7 in number. The cervical vertebrae, which are the neck bones or bones found on the neck regions, they are 7 in number. From the 33, they are 7. Then we have the thoracic vertebrae. So when you talk about the thoracic vertebrae, these are bones that are found in at the back regions, or basically where we call it the thoracic regions, just behind the chest. Behind the chest, that is where we have the thoracic vertebrae. In fact, if somebody asks you where the thoracic vertebrae, you just need to say in the thoracic region or the chest region. So the thoracic vertebrae, usually they are 12 in number. They are normally 12. So we have cervical vertebrae found in the neck region, they are 7. Thoracic vertebrae, they are found in the chest region or thoracic region, and they are 12 in number. They are 12 in number. Then we have the lumbar vertebrae. Those ones are found in the lumbar region. The lumbar region here, we are talking about the back, around the back region. That is where we have the lumbar vertebrae. Lumbar vertebrae. In human beings, the lumbar vertebrae are 5. In human beings, the lumbar vertebrae are 5. Then we have the sacral vertebrae. This one is normally found in the sacral region, just near the pelvic girdle. Near the pelvic girdle, we have the sacral vertebrae. In fact, who is it?
Animation. 15 minutes.
We are the sacral vertebrae. I'm saying that this one is found near the pelvic girdle. In fact, that is where the hind limb are going to be joined. We have the head of the femur. That is where we are going to have a perforation to allow the fusing from the ball and socket joint. So we have the sacral vertebrae found in the near the pelvic girdle, and in human beings, the sacral vertebrae, they are 5. They are 5 in number. So then we have the caudal vertebrae. The caudal vertebrae here, in human being, it is one of those structures that we call a vestigial structure. because it is basically talking about the tail. It is like bones of the tail in human beings. Like, you know, human beings, they do not have a tail. Yes, it is there, but vestigial meaning that it has been greatly reduced because it is functionless. So it is greatly reduced. So in human, we call it a coccyx. We call it a coccyx. And the number of bones that make up this caudal vertebrae in human beings, they are only 4. Of course, they differ from one organism to another. For example, in cow, I'm sure there are so many. In a goat, there are many. But in human beings, we only have 4. So if you add those bones, like we have said, cervical, there are 7, thoracic, there are 12, lumbar, sacral, there are 5, then caudal, there are 4. You realize that that one is giving you 33 bones. So each bone, for example, the sacral vertebrae, the bones that make up the 5 sacral vertebrae, they have the same appearance. They appear the same way. So we are going to be looking at one at a time. The cervical vertebrae, look at it once at a time. Thoracic vertebrae at a time. Lumbar vertebrae, sacral vertebrae, caudal vertebrae. So for example, when we talk about the thoracic vertebrae, the 12 of them, they have the same appearance. All of them appear the same. So we are going to look at the general appearance. How is it different from the others? The adaptations, the functions, how is it shaped, etc., etc. Then you talk about the 5 in the lumbar vertebrae. They are all the same. They appear the same. They have every morphological feature appearing the same. So we are going to look at them each at a time. Then the cervical vertebrae, you realize that there are 7. I said there are 7. So the first one I told you, it is the one that is supposed to articulate with the skull to form, to allow the nodding of the head. That bone, the first bone of the cervical vertebrae, is called the atlas. Below the atlas, we have the axis. So axis and atlas, we are going to look at them separate or separately from the others. That is because in as much as we are saying that the bones, for example, the cervical vertebrae, they are all the same, you realize that the atlas and the axis, the first 2 bones of the cervical vertebrae, they are the same. They are not the same with the other 5. They have some differences. They have some characteristics that are not visible in the other 5 bones. So we are going to look at them separately. Then all the others, we are going to be looking at them together. Look at the distinguishing characteristics, the appearance, etc., etc. Those are the 5 regions or the 5 categories of the vertebral column. We have the cervical vertebrae in the neck region, thoracic vertebrae in the chest region, lumbar, sacral, and caudal vertebrae in that order. And we have said they have the specific number. You have a question? Anybody with a question or require a clarification? Are you following?
Yes.
Yes.
Any question?
Yeah.
So if there's no question, maybe we can carry on. So you can see here, I'm projecting a subtopic in bold saying the basic plan of vertebrae. When I say the basic plan of a vertebrae, the 33 bones, there are some features that we are going to be seeing are common in all the 33 bones. So when I say the basic plan of vertebrae, I'm trying to say, what can we see in the bones from the first bone of the cervical vertebra, that is the atlas, all the way to the caudal? We have some features that are common in all the bones. They have the same function. So once we talk about the basic plan, as we move forward, we are going to be seeing what now differs is the appearance. Some are elongated or they are long. Some are not there. For example, we are going to see some features are not there in the sacral vertebra, but they are there and very prominent in thoracic vertebrae. But now the function does not change. The function does not change. For example, if we say they have a neural canal or neurospine or the transverse processes, the transverse processes in thoracic vertebrae will have the same function as the transverse process in lumbar vertebra. So the function remains the same. That is why we are saying the basic plan of a vertebrae. So the general appearance, they have the following features in common, and the features have the same function, regardless of whether it is found in sacral vertebrae, it is found in cervical vertebrae, thoracic vertebrae, wherever it appears, the function cannot change. What is going to change is simply the appearance. Maybe in some points, they are long. In some other bones, they are short or reduced. In some bones, for example, the sacral vertebrae, we are going to realize that the transverse processes are greatly reduced. Moving downward to where we have the caudal vertebrae, we realize that we do not have the transverse process. So where it is there, if it is there in the cervical vertebrae, the function does not change. It remains the same throughout the bones whenever it is there. So I'm sure you can see that one, the diagram. I'm sure you can see the diagrams there. The first diagram there is showing the neurospine. That is how the basic plan, when you have a vertebrae, it is supposed to show you these features here. It is supposed to give you the neurospine. It is supposed to show you the neural canal, the neural arc. It's supposed to show you the vertebral canal, the centrum, which is a solid body, to provide support. We have the transverse processes. All of them in the second diagram, now it has been given in a different view. We have the neural canal, neurospine, articular facets, transverse processes. We have the centrum of the body. So those are the parts that you are going to be seeing over and over again. So the first thing that we must be able to do, we must have those parts and their function, because now, once we start dealing with the cervical vertebrae there, when I say the centrum, you should be able to know the function of the centrum in any bone. So the first thing that you need to know, you must know the parts and their function. So under your, where you're taking notes, write the basic plan of the vertebrae, basic plan of the vertebrae, the basic plan of a vertebrae, the basic plan of the vertebrae. Then, before you write anything, you say that although there are 33, although there are 33 bones of the vertebral column, although there are 33 bones of the vertebral column, they all conform to the same basic plan. They all conform, or they all conform to the basic plan. Then you see that the following features are found. The following features are found in the vertebrae. So we start with the number one. Number one, the centrum. You can see where the centrum is there. You can see the centrum there. The following features are present. Number one, we have the centrum. So the centrum, whenever we have the centrum in the sacral vertebra, thoracic vertebra, cervical vertebra, the function does not change. It is still the same. So the centrum and its function, you see that hyphen, centrum, hyphen, you see that it's a solid structure. A solid structure. A solid structure that supports the weight of the vertebra. That support the weight of the vertebra. A solid structure that provides the weight of the vertebra. So whenever you are told to give the function of the centrum, of course, you are going to be given a diagram there without the naming. For example, you are going to be told, name the part labeled X. Maybe X is a centrum. Then you give its function. You have to tell me, you have to state the statement like it appears as an adaptation point. Like it is solid to support the weight of the vertebra. So that is number one. Number two, the transverse processes. Look at the second diagram here on your right of the gadget that you're using here. The transverse processes. This wing-like structure here, they are found on either side. We have a transverse process here. We have another transverse process here. On the left-hand side, your diagram, the transverse processes are also evident. You can see it here. You can see it here. So you can see they are elongated, they are large, they are long. So the transverse processes, hyphen, transverse processes, the transverse processes, they are wing-like structures. You said they are wing-like structures. They are wing-like structure projecting. They are wing-like structures projecting laterally to the centrum. They are wing-like structure projecting laterally to the centrum, projecting laterally to the centrum to offer surface for muscle and ligament attachment. Wing-like structures projecting laterally to the centrum to offer surface for muscle and ligament attachment. Projecting laterally to the centrum to offer surface for muscle and ligament attachment. Number next is the neurospine. The neurospine, you can see it here on the diagram here. This is the neurospine, the one that look like a spear. It's sharp, it's long. You can see here. In some vertebrae, they are long. In some, they are greatly reduced. Neurospine here. So the neurospine, you say that it is dorsal projection to the centrum, dorsal projection to the centrum, dorsal projection to the centrum to offer surface for muscle and ligament attachment. Dorsal projection to the centrum to offer surface for muscle and ligament attachment. To offer surface for muscle attachment. That is the neurospine. You can see it here. The other thing about them is that the neurocanal, you can see it's a canal here. Canal, the canal here. It's like a cavity, the neurocanal. like a cavity. You say that it is centrally positioned canal. This is a centrally positioned canal. Centrally positioned canal. Centrally positioned canal to allow passage of spinal cord. Allow passage of the spinal cord. Spinal cord passes through the neural canal. Then we have the neural arc. Neural arc. This is the neural arc. If you can see where I'm placing my cursor here. Okay. This one here is the neural canal. Here. That is the neural arc. Here. Again here. You can see we have the neural arc. The neural arc there, you see that it arises from the center. Arises from the center. Arises from the center. And together with the center, arises from the center, and together with the center, and together with the center, we protect the spinal cord. We protect the spinal cord. So if you look at this centrum here, this solid structure that you are calling the centrum, this one here, moving like this in this direction here, that is where we are having the neural arc. And that is why we are saying that the neural arc arises from the centrum. So together with the centrum, the neural arc and the centrum, they both work together to provide protection to the spinal cord that we are saying is passing through the neural canal here. So they are going to provide protection. That is to say, the neural arc work together with the centrum, and that is why we did not give that function under the centrum here, that it provide protection to the spinal cord, because it cannot provide protection to the spinal cord if the neural arc is not there. So the neural arc, together with the centrum here, they provide protection to the spinal cord that is passing through the neural canal. That is passing through the spinal, the neural canal. The other thing is the articulating facets. Articulating facets. So look at this. Here we have the articulating facets here. This one. We have the articulating facets. To articulate means to join. To articulate means to join. So that is where one vertebra is going to be connected with another vertebrae to form now the spinal cord or the vertebral column. So these articular facets or the articulating facets, they basically provide a surface for attachment, or to provide a surface whereby the backbone, the vertebra is going to be connected with each other. Of course, the vertebra is supposed to be connected on the upper end and also on the lower end. We call them the anterior end and also the posterior end. So we have, therefore, the posterior facets, and then we have the anterior facets. So the anterior facets, we call them the pre-zygapophysis. This one, basically, they face upward and also inward. Then we have the one that are found on the posterior end, and we call them post-zygapophysis. Basically, they face downward and outwards. So under articulating facets, under articulating facets, you say that the vertebrae articulate with each other by facets. They articulate with each other by facets. Full stop, another line, you say that the facets on the anterior end are pre-zygapophysis. The facets on the anterior end are pre-zygapophysis. Then the facets, facets on the anterior end are pre-zygapophysis. Into bracket, you say they face upwards and inwards. They face upward and inwards. Face upward and inwards. Then we have another line under articulating facets. You say the facets to the posterior end are post-zygapophysis. The facets on the posterior end are post-zygapophysis. Usually they face downwards and outwards. Bracket that. Facets to the posterior end are post-zygapophysis. Bracket, they face downwards and outwards. Now, there is something that you need to note. There is something that you need to note and note it clearly. When you talk about any projection, any bone that is projecting or okay, sorry. I was saying, when you are dealing with the vertebral column, any projection, I'm repeating, any projection, talk about the neurospine, talk about the transverse processes. We are going to also to see some other projections under the caudal vertebrae that we call, for example, we have, can remember, we have metapophysis. It is a projection. Any projection, when you are dealing with the bones, they all provide surface for muscle attachment. Maybe you can note that one somewhere, that projections on the vertebral column provide a surface for muscle attachment. This projection become the neural spine, the transverse processes. We have another one that we call the metapophysis. That one is only found in the lumbar vertebra. All those projections, they provide a surface for muscle attachment in the projection. When you talk about canal, when you talk about a canal, this vertebral canal, it is going to provide it is going to allow passage of the spinal cord. Now, in the in-chat messages here, I've seen somebody say that what is a ligament? Somebody is asking what is a ligament. The ligaments, they are basically, they are supposed to connect bones to another bones. Remember, for example, when you are forming a joint, for example, the lower limb, for example, the tibia and the femur, those two bones are supposed to be connected together to form a joint at the knee area. The structures that connect the bones to the bones are referred to as the ligaments. Then I've seen somebody ask, what is the difference between a spine and a spinal cord? Now, the spinal cord, it is like, it is the structure that is passing through the neural arc. The structures that is passing through the neural arc. The neural canal, so through the neural canal. This one, we are going to look at it again under response and stimuli. We are going to realize that it is made up of the gray matter, the white matter, etc. Basically, the spinal cord is going to be involved in, the spine and the spinal cord. Oh, okay, I got you. This is treasure. The spine, this projection here. Treasure, this projection here, if you can see where I'm pointing here, this projection here, that is coming from, it is one of the parts that make up the vertebrae. That is a neurospine. That is the neurospine. This one here, that is the neurospine. When you talk about the spinal cord, that is another name of the vertebral column. Sometimes you call vertebral column spinal cord. It is one and the same thing. So the spinal cord are the bones, and the bones that are making up the vertebrae. All the 3 bones, they form the spinal cord. When you talk about the spine, I've shown you this is the spine, the neural spine here. Somebody is saying, repeat on zygapophysis. On zygapophysis, I've told you that these ones are facets, they are articulating facets. This is where one bone is going to be connected with another. One vertebra is going to be connected with another. And we have the 2 types of zygapophysis. We have the pre-zygapophysis. The pre-zygapophysis here, they are anterior. So that is where they are, this is anterior. Anterior meaning on the front end. Then we have the zygapophyses that are found on the posterior end or the back end that we call the post-zygapophysis. So basically, the zygapophyses are surfaces that allow the vertebrae articulate with each other, in simple terms. Surfaces that allow vertebrae articulate or connect with each other. Those were some of the questions that you had projected. So I was saying that you need to note and note clearly that when you have any projection coming from the bone, or basically the vertebrae, they all provide a surface for muscle attachment. They all provide a surface for muscle attachment. When you're talking about the canal here, you are going to see it over and over again. That one allow the passage of the spinal iron. So we are back to this one here. So these features here, we are dealing with the basic plan of the vertebra. All those features, we are going to be seeing them in the 5 vertebrae. So we start with the first vertebra here. That was the cervical vertebra. The cervical vertebra. That should be the next area we are supposed to look at. The cervical vertebrae, I think I mentioned and said that the cervical vertebrae are found on the neck region. They are found on the neck region. Again, there are 7 in human. In human beings, there are 7. I told you that when we are dealing with this support and movement, our reference point will be human being. So in human, we have 7 bones that are making up the cervical vertebrae. They are found in the neck region. The 7 bones of the cervical vertebrae, they have one characteristic in common. One characteristic is common in the 7 bones that are making up the cervical vertebra. And that is, they all have vertebrae canal for passage of the vertebral artery. I think you need to note that. As a note, or vertebrae canal, sorry, all the cervical vertebrae have vertebrae canal. All cervical vertebrae have vertebrae canal for passage of vertebral artery. All cervical vertebrae have vertebrae canal. That one is very important. I'll take you back to this one here, this bone here. Let me take you back here. The first bone here. Let me highlight it kidogo. Let me highlight this one here. This bone here. Somebody might draw this bone for you, not label anything. And then the first question there, identify the vertebral bone or identify the vertebra above. Identify the vertebra above. That is in an exam situation. These are some of the things that you are going to experience. Identify the vertebra above. You will be able, you are going to be forced to analyze this diagram and come up with the correct identity of this one here. For example, if I may ask, with the hands, which vertebra is this one here? Which vertebra is here? Am I highlighting here? There is somebody called Andrew here.
Andrew. Cervical vertebrae.
Cervical vertebrae. I agree. Give a reason.
This is due to the presence of the vertebral canal.
Vertebrae canal. You will not find vertebrae canal in any other vertebral bone. But you can see it is here, the one that I've circled there. This is the vertebrae canal, which you will not find in any other type of bone. It is only found in cervical vertebra. That is the first marking point. And now there's something that we normally insist in class when you talk about tied question. So if you cannot identify that this one here is a cervical vertebrae, then be part of it you cannot score because you identify the bone, you give a reason. You already missed 2 marks. Then number 3 is going to tell you, identify the region where it is found. Then you tell me it is found in the neck region. That is true, but remember you did not score in A. In B, you did not score. So we are going to give you a score, a tick, and give you a 0, meaning that the question was tied. And of course, the other question comes from you being able to identify the parts properly and being able to give their function. So it is your responsibility to analyze this diagram there. That point that I've told you that in cervical vertebrae, all the cervical vertebrae have vertebrae canal for passage of the vertebral artery. That one, you need to note it better. You need to note it better. So again, I think I told you the 7 bones of the cervical vertebrae. The first 2, that is the atlas and the axis. The first 2, we call them the atlas and the axis. They differ from the rest. They have some distinguishing characteristics that are not found in the other 5 cervical vertebrae. So we are going to look at the first 2, that is the atlas and also the axis. And then we are going to give the general characteristics of the others. Features under the cervical vertebrae, I think you say that they're found in the neck regions and there are 7 in human. Then I'm sure you wrote an NB, whereby you said that all cervical vertebrae have vertebratory canals for passage of the vertebral artery. So we start with the first bone there, the atlas. The atlas. The atlas. You can see the way it appears. Some of the features of the atlas, you realize that the neurospine and the centrum are small. Yes, they are there, but they are small in size. The fact that they are small and the centrum is also small in size make it different from the other 5. You realize that in the other five, because we are saying there are 7, but the first 2, atlas and axis, they are different. One of the differences is that the atlas has more neurospine and centrum. That is to say, the others, they are large in size, they are large in appearance. The neurospine and the centrum in the atlas, they are small in size. You can see them here. You can see this one here. It appears like the general appearance of this bone here looks like a shot, kind of. The one that looks like a shot, definitely you will be able to know that this one here is an atlas vertebrae. One thing about them, they have a small neurospine and the centrum. Number 2, the other thing about them is that they have a wide neurocanal. They have a wide neurocanal for passage of spinal cord. Passage of spinal cord at the neck region. We have a large or a wide neurocanal for passage of large spinal cord at the neck. Now, we cannot be able to see it in this diagram here. But now, once you come back, of course, this is a practical topic. We are supposed to be studying this one in the lab because we are supposed to identify the feature and we see it. So once you come back, of course, each class with their respective teachers are going to be taken to the lab. Then you see the bones. There are so many bones in our lab. So we are going to analyze and we see the wide neural canal that is found in the atlas that allow the passage of the wide or large spinal cord. Again, we are going to see the spine and the centrum on the atlas being small in size. Those features are going to be evident. Then the other thing is that about the atlas is that they have a broad transverse processes. You can see them here. This broad transverse process, at least this one here is evident. It is broad. This one here also is broad. They have a broad transverse processes, which are wing-like, of a larger surface or muscle attachment in the neck region. You can see them here. They have a broad transverse processes. Which is wing-like. You can see they look like wings. And then this one of a larger surface area for attachment of neck muscles. It is not large for nothing. It is supposed to provide a surface for attachment of neck muscles. The other thing is that they have broad facets. Broad facets for articulation with the condyles of the skull. Broad facet for articulation with condyles of the skull to form a joint that allow nodding of the head. broad facet for articulation with condyles of the skull, form a joint that allow nodding of the head. I'll take you back kidogo. I'll take you back to the skull here. Look at this. Remember I told you here, that is where the atlas, look at the last point here. I told you that at posterior end, the skull has smooth, rounded protuberancles and the occipital condyles, which articulate with the atlas vertebrae to form a joint that allow nodding of the head. So the facets that are found on the atlas are supposed to articulate, they're supposed to join together, they're supposed to articulate with the occipital condyles and the rounded protuberancles that are found in the skull to allow formation of a joint that allow nodding of the head. For the side-to-side movement, that joint is formed when the axis, the second bone of the cervical, articulates with the atlas. So for the nodding of the head, it is due to the formation of a joint that is formed between the atlas, the facets of the atlas that articulate with the occipital condyles, allowing nodding of the head. That one is evident here. These are the facets that we are talking about. These are the facets that we are talking about. You can see they are large in size. They are large in size. Large facets to allow for articulation with the protuberances and also the occipital condyles of the skull, thus allowing nodding of the head. That is up and downward movement of the head. Those are the distinguishing features that you find in the first cervical vertebra. Then we have the second one. So you need to leave some lines there. If you are taking notes, you need to leave some lines, like 4 or 5 lines to draw a diagram of the axis. Then we have the second bone there. That is the axis. This is now after the atlas. The second bone of the cervical vertebrae is the axis. This axis is supposed to join with the atlas to allow for the side-to-side movement of the head due to formation of a joint there formed between the axis and the atlas. So the features of the atlas, number one, is that it has an ondotoid process. This is a modified centrum here. It's a modified centrum that we call the ondotoid process. So one of the features of the axis is that it has an ondotoid process. Ondotoid process that fits into the ventral side of the neural canal. Ondotoid process that fits into the ventral side of the neural canal of the atlas. It fits into the ventral side of the neural canal of the atlas to form a joint that allow side-to-side movement of the head. So this peg here, this peg-like structure, the peg-like structure here that we are calling the ondotoid process is supposed to fit inside the neural canal of the atlas. The atlas is the first bone of the cervical vertebrae to allow head, to allow side-to-side movement of the head. The other thing that is different from the other bone and is found in the axis here is that it has a broad neurospine. Of course, this diagram is not 3D, therefore we cannot see some of the features. Those features can only be seen when you are dealing with the specimen with the physical specimen now. Of course, that one we are going to do in the lab. We are going to see the broad neurospine. The other thing is that they also have wide neurocanal. Wide neurocanal. They have a wide neurocanal. Wide neurocanal. Again, this one here is not 3D, therefore it is difficult to see the wide neurocanal. But once you come back, be sure you're going to proceed to the lab to see these features. The other thing is that they have large wing-like transverse processes. Large wing-like transverse processes. The transverse processes, we say that the functions do not change. So as long as it is a transverse process, the function is the same. The function is the same. Large wing-like transverse processes, if you want to complete the line, just say that is supposed to provide surface for muscle attachment. 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 Those four features are different. You cannot see them in the other five. The first two cervical vertebrae, atlas and the axis, they have some features that are not evident or they cannot be seen in the other five. However, all the other five cervical vertebrae have the same features. Which are the other features? I can maybe conclude by looking at them. So leave some 4 or 5 lines again to draw the diagram of the axis there. 4 or 5 lines to draw the diagram of the axis there. Then you see that the other 5 cervical vertebrae, they have the following features in common. They have the following features in common. Number 1, broad branched transverse processes. Broad branched transverse processes. Broad branched transverse processes. Of course, we all know the functions of the transverse processes. That was the first thing that we talked about. And it is simply to provide a surface, a larger surface. And I'm insisting on the word larger surface for attachment of neck muscles. Broad branched transverse processes, which are larger, which provide a larger surface area for attachment of neck muscles. The other thing is that they have a short neurospine. So even if the neurospine is short, even if it is long, the function does not change. It is supposed also to provide a surface for muscle attachment. It is supposed to provide a surface for muscle attachment. Supposed to provide a surface for muscle attachment. The other thing about the other 5 transverse processes is that they have a wide neurocanal. Wide neurocanal. This one allow passage. Wide neurocanal to allow passage. Wide neurocanal to allow passage of spinal cord. Spinal cord. Then lastly is that they have a wide centrum. Wide centrum, of course, that is to bear the weight of the vertebral column or to support the vertebral column. Wide centrum, that is to bear the weight of the centrum of the vertebral column. So that is the cervical vertebrae and the features. So whatever is remaining is the practical bit. That is, of course, you seeing the bone, identify the features, and of course, the functions of the features identified. So I think unless somebody has a function, has a question, sorry, we can stop there. Somebody is asking there whether the axis and the atlas have a centrum. Yes, it is there. It is there. It is there. So maybe I can clarify. The 4 features that we have highlighted here on the other features of the cervical vertebrae, they are also present in atlas and axis. In addition to that, they have the features. The atlas and the axis have the features that we have also discussed there above. So yes, the centrum is present. The centrum is present. Somebody is asking which website can we get the notes? These are not website notes. They are PDF notes. I have them in my laptop. These are not notes from the PDF. They are my notes. Maybe I don't know. Maybe I can share them with one of the students. I'm going to think I have an email of somebody from the classes that I handle, that is 3 and 3D. Maybe I am going to channel them. There is a guy called Mukoya Kisa in 3A. Mukoya Kisa, maybe you can WhatsApp me. I am sure you have my number. You WhatsApp me, I'm going to share with you these notes. Then you distribute with your colleagues in the other class. So maybe we can stop there for now until next time. So you have a good day. See you next time.
Thank you for the lesson.
Simon, thank you so
Thank you.
for the
Thank you for the lesson.
Thank you for the lesson.
Thank you for the lesson. Thank you. Thank you for
Thank you, Malim.
Thank you.
Thank you.
Arama focus.
Thank you.
Thank you.
Thank you. Thank you.
Thank you, teacher. Thank you, teacher.
Thank you, teacher.
Teacher.